Kendrick, the one with the rocket science shirt.
Kendrick.
Kendrick. This is Aiden.
Aiden.
This is
Charles.
Charles.
And then another Aiden.
Another Aiden. Aiden and Aiden.
Yes.
All right, Charles. We'll remember your name because our first great-grandchild's name is Charles.
No problem.
Our only great-grandchild. All right. So, anything else you want to say before I start?
Not really. I don't.
Okay, how do you see this going? I mean, what's the procedure you see?
We have some questions that we want to ask you because our project is about space junk. So we have some questions about Cassini and about all the space junk that's happening, all this project right now.
Okay, that sounds good. All right. Well, let me tell you just a little bit about myself first. I married this beautiful woman over here 60 years ago. 60 years ago. This month. And we met in Pasadena. And there's a famous technical college in Pasadena. Who knows the name of it? Caltech. Caltech. You've heard of Caltech? Everybody's heard of Caltech? Okay, I worked there for a couple of years on a project that we'll talk about a little bit when we get into space junk. Anyway, I put a picture up here. Who knows what that is?
Saturn.
Saturn. Good. You guys know your planets, huh?
Yes.
Okay, the closest planet to the sun is?
Mercury.
The next one?
Venus, Earth, Mars. Saturn,
Jupiter.
Jupiter.
Saturn. I think you said that wrong.
Mercury, Venus, Earth, Mars. Jupiter, Saturn,
Okay.
Neptune.
That's pretty good.
It used to be Pluto.
Well, you know, they're talking about making Pluto a planet again, you know. I think,
That would be really difficult because I heard about last year that it was supposed to be like anything smaller than a star, but bigger than
there's talk
like an
about-
asteroid. And then that would make all the moons planets, and that would be like 200 moons,
I don't-
200 planets.
I don't think Pluto probably cares, but I'm going to call it a planet. Anyway, okay, we've got one more person.
Yeah.
So you could introduce.
This is Calvin.
Another C, Calvin.
I put a chair just beside the door there.
Calvin. You're going to find this difficult to believe. All these chairs you're sitting on, except these two here. These 4 chairs right here came from Caltech. Wow. This is Caltech Geology Department. I mean, can you believe they bought a whole bunch of new metal chairs and threw these wooden ones away because they were all old and ugly looking? So I brought them home and sanded them all down and refinished them. Now they're beautiful again. Anyway, we got about 10 of those. All right. Where were we? I started working at the Jet Propulsion Laboratory in 1980. But before that, I worked at a company called PerkinElmer Corporation. Anybody heard of that? PerkinElmer?
I heard it before.
I've heard of it.
They built a lot of fancy optics, including the optics for the Hubble Space Telescope. Who's heard of the Hubble Telescope? All right.
Doesn't that picture taken by
That picture there of Saturn was taken by the Hubble Telescope, yes. Yes, and it's still up there doing its thing, taking pictures.
it broke one time it kind of broke and the pictures it took became unclear.
Oh.
I remember that.
I can tell you all about that for about 2 hours, but I'm not. Anyway, So you're here today to ask a few questions about space junk and maybe the Cassini spacecraft. I'll ask you, how do you spell junk? How do you spell Cassini?
Caffini.
Close. Never, Cassini.
Caffini.
Closer. Anybody? It's tricky.
Oh, I know Cassini. Is it like Cassini Huygens? Is it Cassini Huygens? It wasn't like the Cassini
Huygens?
Huygens.
Huygens. Yeah, that was the probe that they dropped on Cassini's largest moon, which is called Titan. Very good. All right, the Cassini is Cassini. And if you can spell that at the end of our little session today, I might give you a prize.
Isn't it right here? It's over
Yeah.
Oh no, they're cheating.
No wonder you got it wrong. Anyway, we're glad to have you in our home. I retired from JPL and Caltech in 1996. When were you guys born? What year? 2007? 2005?
2008.
2008? All right. See, to you, all of this is old stuff. I mean, it's nothing fancy. But when I was born, there weren't any spacecraft. There were only stories about spacecraft. And one of my favorite radio programs was called Buck Rogers. You ever heard of Buck Rogers? He flew around space in a rocket ship and had a lot of adventures. It was sort of like Star Trek. But we thought that was pretty exciting back in the 40s. Okay. Let's talk about some of your questions. Who wants to go first? We'll see if we can answer them. Let me explain something. I am not a scientist. I am an engineer. You know the difference?
Yes.
What does an engineer do?
Build things.
You design things, you test things, you build stuff. What does scientists do?
Research.
Research using the stuff that you do.
Okay, they use the instruments that engineers build, and then they get all the glory, see? The scientists get all the glory. So if you want the glory, become a scientist. If you want to really do something that's interesting and fun, then you can be an engineer and build all sorts of things. Okay, so I'm an engineer and I'm not an expert on much of anything except I was an optical engineer. So the optics has to do with
Vision.
eyes, your glasses, your lenses, cameras, anything to do with lenses and mirrors and light, okay? I've always liked light. What would we do without it?
Pretty much, we can't really do anything.
That's right. Okay, so with that in mind, let's have a question.
Did your team have to deal with any problems because of space junk attack?
Space junk, you know, since, no, we didn't. Not exactly. Not that we know of. But I looked up a little bit about space junk, and I'm wondering what all you've been told about it. The Earth's a big place, and there are like, how many satellites in orbit right now?
Like around 100?
Like about 2,000. The source I had said there were about 2,000 satellites in orbit around the Earth now. And how many pieces of space junk?
3 million?
More than that,
A lot.
like 400 million.
Right, 380 million.
Well,
More than that.
the number I saw on the site I searched said 500,000 or so, but who knows? What is space junk?
Pieces of.
Pretty much anything that humans sent into space now is just orbiting Earth without anything to do. There's nothing it just has, it's like pieces of things that don't have much use anymore.
And are just bound to collide with something.
Okay, so they're just all over the place in orbit around the Earth out there, just hundreds of thousands of pieces of stuff, from little things to bigger pieces of things, right? And what's the problem with that? What's wrong?
It's gonna collide with something eventually.
Like spacecraft or satellites.
Does that ever happen?
Yes.
Yeah. So, what's the biggest thing we have in orbit now?
ISS.
Yes. Has it ever had a run-in with space junk?
Yeah.
Yes.
Every once in a while, and you just hope it isn't too big, and that they can patch it up, or it doesn't do too much damage. But it's possible that it could. There's always that chance. But remember, the Earth is big, and the orbits out there are big, and a couple of million little pieces of stuff. It really isn't very crowded. That's what I'm trying to say. Okay.
But closer it is to Earth is really, really crowded because there's always paint flecks and bolts and things.
Yes. But if you spread 1 million volts around the Earth, it isn't very crowded.
Yeah.
So how serious the problem is kind of depends on your luck and so forth. There's other kinds of space junk too. When I worked for Caltech, we built a camera for the Mars Observer. And this is a picture of the whole spacecraft.
Oh, that one. Wow, I recognize it somewhere.
So this is shown, this is an artist's rendition. This is shown in orbit around Mars. And I worked on the camera with a team at Caltech. And this is the camera right here, this little tube right there. See that? That's a 14-inch telescope. When I say 14-inch telescope, what does the 14-inch represent?
How big the lens is?
How wide the lens
That's, okay, this has a mirror in it. So some telescopes have lenses, some telescopes have mirrors. This one had mirrors in it, okay? And the primary mirror was 14 inches in diameter. And that, at the time, was the largest telescope to leave the Earth's surface, or atmosphere. So, yeah, this is the telescope right here that we built at Caltech. It took us about 2 years to build that. And there were about 10 or 12 of us who designed and built and tested that. My job was to test it and align it, make sure it was all lined up right. So it was launched, and it took quite a few months to get to Mars. And to slow it down on Mars, they had to fire a retro rocket on here. What does retro mean? Retro means like backwards, okay? Retro means to slow it down. So it's going this way, and the rocket will fire that way and slow it down so it can go into orbit around Mars because it's going too fast. Well, something went wrong. We were just about to have our party, a big party after launch. And so they fired the retro rocket, something went wrong, and they never heard from it again. It became, for all intents and purposes, space junk. It wasn't in orbit around the Earth. It will never do any good for anybody because it disappeared in space. It lost in space. How does that make you feel after you work on something for 2 years? You're getting close to seeing it actually operate, because with this telescope on the surface of Mars, you could see things that were only this big while you're orbiting Mars. It was a powerful telescope, and we were looking forward to seeing things we'd never seen before on Mars. And then we tried everything and then never heard from it again. So that's a piece of space junk. Who knows where it is? It's just kept on going out there. Maybe it crashed into the planet. It probably just kept on going. So there's another kind of junk that we don't have to worry too much about because it's way out there. Okay, any other questions there?
You should go down your list of questions that you guys formed.
Was the problem with space truck? Has the problem with space truck increased since 1997?
1997. Why 1997?
I don't know.
Because that was the year where the Cassini was launched.
That's right. That was the year Cassini was launched.
That's one thing that you know me.
Okay. Well, the more stuff they put up there, I guess the more of a potential problem space junk is. And they designed spacecraft, I guess, to be able to take some kind of damage from small pieces of space junk because they know it's there. I don't really know. I'm not too worried about it myself.
That takes up question 6.
I don't have any dog in that fight, if you know what I mean. Anyway, I know they're talking about collecting it, trying to gather it up. One thing that I found was quite fascinating was a group of students, I forget at what college, were addressing the problem of space junk. And they said, why don't we, when we put up a satellite, make it so that when it's ended its usefulness, it will come back to Earth and burn up sooner. Now, how far out from the Earth does the atmosphere go?
100 kilometers about.
Well, quite a ways. And there are spacecraft in orbit around there where there's very thin atmosphere. And what does that atmosphere do?
Yeah. Oh, wait.
Heat it up.
Heat it up.
It slows it down, right? It's very thin atmosphere up there where they put the satellites. And that slows it down. So eventually, as it slows down, it gets closer and closer to the Earth. And eventually then it'll spiral in and burn up. But that might take 100 years. Meanwhile, we're launching all these satellites. And they're getting to be smaller and smaller, and more of them.
CubeSat.
Yeah, that one spacecraft went up and put out about 57 satellites in a row all around the Earth for communication purposes.
I heard there was that before when they were still trying to figure out how they were going to send radio waves to all these radios, they put a bunch of copper wires up there around Earth, and they just formed huge chunks.
I haven't heard that. That sounds interesting. Anyway, these students came up with an idea I thought was fascinating. There is a little bit of air up there, but the drag on a small satellite is very small. So they said, why don't we make a deployable drag chute that pops out and gets big, so it slows it down faster, and then it'll come in and burn up in just maybe a few days or weeks instead of years and years.
Yeah, I think they actually went to NASA. They're actually trying to design something for that.
Did you see that article?
Yeah.
Well, how could they fold up a parachute in a little small satellite that was big like that?
They actually get in.
They got some interesting materials. This is some very thin mylar. It's quite strong. But it folds up into a very small package. So you could make a pretty big drag chute from material like that to slow down the spacecraft. I thought that was pretty ingenious. So that was thought up by some students.
Is that kind of the stuff that's around those satellites, like folded?
That is. Great blanket. If we have time at the end, I will show you a space blanket. Anyway, it's made out of this kind of material, mylar, very thin, quite strong.
Where did you get that?
I got that at shape yet. Okay.
What's
So,
the next question?
Space junk, how would you go about building something that went around collecting this stuff? I think some of the big ones are the ones that they want to get rid of first because they might cause more damage. Yeah, so I don't know, they might want to direct those in to burn up sooner.
We kind of thought outside solutions already.
All right,
So we put.
Are you done with the questions yet, though?
Since he's talking about the stuff and
since we're talking about space junk, and
might as well do the solution.
what are some of your
Okay.
ideas?
All right.
So we could do something like, so we kind of thought like making a robot that pulls fabric behind it, but it has rockets too, so it's able to propel itself, even though it'll have some drag. So the fabric will, when all the space junk that's flowing in the other direction or just floating around, not really in orbit, will float into the fabric and get caught.
Like a fish net, huh?
Yes.
That sounds interesting.
Except the thing with the fish net is that the smaller particles will go straight through the net. It's not going to get caught.
Okay,
So this one's able to clean up everything that's possible.
okay, so finer net. All right. What else?
What's the next question?
Like you have like a magnetic space junk out of there. There's like a space junk like a huge magnet on it to like collect all the magnetic space junk.
How much magnetic space junk is there out there?
A lot.
Magnetic?
Like is it all the rockets?
There could be like small, like, I don't know,
It's the paint chips that are the most.
What-
It's all the small ones.
What's magnetic?
most kinds of metal. Most.
Long stages of rockets.
Iron, steel, and some steel. Is aluminum magnetic?
Not really. But aluminum is what they use.
And a lot of the spacecraft parts are made out of aluminum. Everything that I ever worked on was made out of aluminum or composite materials, plastic and fiberglass and stuff like that.
But meteorites have
Metal.
metal in there.
It's very hard.
A lot of meters have iron in it.
But it also might act like a reflection system.
I have a
too.
question.
It's meteorites. We can, like one day if the giant meteorite coming up, set up a bunch of magnets right behind the thing, or pull it back, slowing it down. And then we can send something else up there and then capture it,
Or
bring
detonate
it back
it.
out.
Or
Okay,
detonate it.
keep thinking. Any other question?
Forgot.
All right. Next question. Charles.
Me? Okay, does the Cassini have any adaptations to help it against space junk?
Adaptations. Not that I know, not particularly. They do have space blankets around them that will help protect against small stuff. But I think mainly that's just for thermal control. And we'll talk about that a little later if there's time. But Cassini space is mostly a lot of empty space. But Cassini didn't have any problem with that. It functioned all the way through its mission until the very end. How many of you have seen any videos about Cassini?
It seems really sad because it's functioned like so many years.
Okay, so you watched that video, the grand finale,
Yeah.
where it showed how it burned up in the atmosphere of Saturn?
Yes.
Yes, a lot of people got tears in their eyes. This was like an old friend. Okay. Next question.
I have a question that's not really related to space junk, but have you heard about how in mission control, like before one of the Apollo 11 landing, this person gave out peanuts when they had this tradition.
Oh,
Yeah.
yes, I've heard of that, up in space control. Yeah, I've never gotten peanut for that. But, yes, it's fun to have traditions like that. So it is true. Okay, next question.
How long does a average satellite function for?
Well, that's a good question. Some of these satellites have been, depends on their function too, I guess. But some of them have been up there for many years. They get their energy from the sun, solar cells, and they can function many years. These communication satellites, which we rely on for our GPS. GPS stands for?
Global Position Information System.
Very good. GPS. I signed some of my emails to my grandchildren GPS. That stands for Grandpa Steimle. Anyway, they look to me for direction. That's a joke.
Yes, we all do.
Okay, there was one they put up many years ago, which was a big mylar balloon. That was a huge balloon, just so we could see it from the Earth. And it lasted for many, many years. Didn't require any power, and it didn't do anything. It just went around the Earth. But they want these communication satellites to last a long time, so unless they get damaged somehow or other with solar power, they could go for years and years. Some are just made for a specific length of time. When they last longer than that, everybody's happy.
So basically, the rat break is basically now the, what's it called? Nylon.
But this
Yeah.
is a thermal blanket. It's coated with gold because gold reflects infrared. Infrared is the heat, right?
So, I'm kind of frazzled. Very frazzled.
What's that?
I'm worried that they put together this list of information and it's, 20 to 3 and
Okay, let's go through your questions.
You have more questions? What's the next question?
How long does it take a satellite to orbit Earth about?
You need to get up to orbit, from launch
Yeah.
to orbit.
Yeah.
doesn't take that long.
No, it's pretty fast, I guess, in an hour or something, or it gets up there pretty quick. Now, in Earth orbit, it's usually traveling about 16,000 miles an hour, give or take. So it's accelerating quite rapidly. But it's just a matter of an hour or so, I would think. You could look that up. I've never launched one, so. Next question.
Well, doesn't how long it takes to depend if it's the geothermal orbit or global orbit?
Geosynchronous orbit? Yes. What's geosynchronous orbit?
I don't know.
It's the
It's
satellite hovers over the same area as the Earth's turns.
That's exactly right. And to do that, it has to be at a certain altitude. Anybody know, want to take a guess what that altitude is? It's higher than the average satellite. That's true.
Around like 700 kilometers.
About 24,000 miles.
There are satellites.
So that's way out there. Then, as the Earth turns, the satellite stays over the same spot on the Earth. Isn't that clever to be able to do that?
Why does it have to be at a certain altitude?
Because if it's in closer, what happens?
It's faster.
It
Travel
goes
speed.
faster. Closer it gets to the Earth, the faster it goes. If it didn't go faster, it'd fall right into the Earth. Good question. Next question.
No, but then some of them kind of party next to the number 6.
I
Okay,
want number 8. Let's do number 8.
But then you said there wasn't much space junk when the casino launched.
are we through with the questions?
I'm assuming we're through.
All right.
Let's try it.
But then that's kind of the same thing as 6.
Let's try it.
What's number 4? What's number 4? Read
Do
it.
you believe space junk is and will be a major problem in the future?
I think it's a problem that needs to be studied and addressed. So many satellites have gone up, and so many more are going to go up, that they have to keep track of these things. I worked on a project in New Mexico. We built a couple of telescopes for a station in New Mexico. That the 2 telescopes were for tracking satellites. And they were really interesting because they had a big computer there, and they would track satellites, and they'd keep a catalog of all the satellites. Because a satellite, once it's in orbit, you can calculate where it's going to be at any time, right? Because it's like a clock. Now, it's like a pendulum clock. It just keeps going around, and you can calculate. If you see a satellite at a certain place at a certain time, at this facility, they could tell you what satellite that was, when it was launched, and who launched it. And so what they were doing all the time was looking for new satellites. And when they'd find a new one, they'd compare it with the catalog in their computers and say, this is a new one, and then they'd announce it. We think we found a new one. It's at this coordinate, this space, this time, this speed, this orbit. And they'd say, yeah, that's a new one. They'd add that to the catalog. It might be a Russian one, it might be from any country. But they keep track of all the satellites, and they keep them cataloged. And I don't know how many of these pieces of big junk they keep track of, but I think if they're big enough to see through a telescope, they want to know where they are and keep track of them. So I think it is a problem that needs to be addressed and studied and understood. But you have to be careful not to believe everything that you're told. Because some people have different motives for doing things. Like if I somehow developed a device that would collect space junk, I would want to exaggerate the seriousness of space junk, right? Because if they said, oh, we better do something, I'd say, buy my machine.
Sure.
Buy my machine. I'll make 100 of them because you need at least 1,000. Right? So you have to kind of be careful. Who's, you know?
Tesla or Tesla? Nikola Tesla or something?
No.
General Custer? No, I never know. You mean Carl Sagan? Not Carl Sagan.
Person who addressed and did the calculations about the Kessler syndrome.
Something Tesla.
Oh,
Dawn.
yeah. Guess what? I saw something about that. That has to do with space junk, does it?
He kind of predicted what would happen with all the space junk.
Like with space junk colliding and then entering the Earth's and going.
Some people think that people from outer space collected space junk and put it in orbit around Saturn.
That's the idea of rings, I think.
Yeah, I don't know. What do you think? Some people think that's where your missing socks are when you can't find them in the wash. There are a lot of theories out there, guys. You'll hear a lot of theories. And always suspend your judgment until you've got the facts, right? Okay, are you through? Anything about Cassini?
Was
My favorite spacecraft.
was there any problems with it when after launch or before?
Cassini was an amazing spacecraft. 'Cause most spacecraft will have problems, different parts of them will go out of order, but Cassini worked right from the beginning, all the instruments, all the way through to the very end. It worked. Now, here's a picture of me. You can recognize me there.
Sadly.
When I was working on an optical instrument, there are mirrors in there. You see the mirrors? He's down in here. This was a special instrument that went on the spacecraft that went to Jupiter, went in orbit around Jupiter. Now this was before that. Juno is very interesting. That's a later one. That's in orbit right now. I'm glad you know about that. That's taking some great pictures, isn't it? Well, this is the one that went on the Galileo spacecraft. You heard of Galileo? Oh, I'm glad that you like Galileo. He's one of my favorite characters. Anyway, the Galileo spacecraft had a lot of instruments on it, and this was a special one that I was working on there. The spectrograph that required some very precise work. My job required a lot of patience and careful for detail. Some people don't like that kind of thing. They'd rather go out and sell automobiles, or something, or other things. Anyway, any other questions?
Oh, yeah.
There's all kinds of videos online. You guys can learn everything. You'll know more than I do in a couple of weeks if you go on. Anyway,
What's the name of that lander that's gonna land in Mars soon?
yeah, Mars has several landers running around, rovers and things. I guess there's going to be another one going up. Instruments always get better and more sophisticated, more powerful.
Mars 2020.
Yeah, it's exciting. Very exciting. Any of you interested in becoming engineers? Scientists? Engineering scientists? Maybe. Okay. Well, we'll kind of wind things up a little bit here. I
A
wanna
little show
you-
and tell.
Show and tell a little bit. I worked on the Hubble camera for the Hubble telescope for about 10 years. I worked on the camera. The camera weighed 600 pounds and it had fewer pixels than your cell phone. This was back in the old days. Technology is getting so advanced now, you can make so much in a small space now. Anyway, something went wrong with the Hubble telescope.
Oh, yeah. Wasn't like it got off, wasn't it like the space junk hit something on it or something?
No.
But I remember seeing something about,
I'm
yeah.
gonna
Space
tell
junk
you,
hit one of the,
panels,
like the solar
solar
panels.
panels or something, yeah. In the beginning, there was a mistake made in figuring, polishing the big mirror. The mirror is 94 inches in diameter. 94 inches, that's about 10 feet, right? No, not that, 8 feet. 96 inches. And something was wrong with it because they didn't take the time to test it as thoroughly as they might have. Wasn't my fault.
No.
I had nothing to do with it. It was made at Perkinoma where I used to work in medical. Anyway, the figure was just a little bit off, just a little bit. Well, it doesn't have to be very far off before the images are blurry.
Mm-hmm.
And so when the telescope got up there and they started looking at images, immediately they knew something was wrong because the images were blurry. You might remember that. So what were they going to do? They couldn't bring it back.
Endeavor service mission.
That's right, a service mission. And it's like, Aiden, where's glasses? Why?
Because his vision isn't
to
as.
correct for the lenses in his eye, right? So that's what they did with the space telescope. They made a second camera with a correction in the mirrors of the camera that was just the opposite of the error in the big mirror. And they made that correction in little mirrors. And they put up a new camera just like this and took out the old one that I worked on for 10 years. That was
Ouch.
perfect. They took it out after 2.5 years or so.
Wait, how did they get on
3.7 years it was up in orbit while they made another one. And they took it up and they took this one out. This is a picture of them taking out the camera that I worked on for 10 years. And brought it back to home here. And that little mirror in there is a piece of that camera that was brought back. Don't read that, just look at the parts. Look at the picture and look at that little mirror.
What is it?
That little mirror there was in that camera that I worked on for 10 years, okay? Don't read it, just pass it along.
Did you make that part?
No, but I put it together and tested it.
That's a mirror?
Yeah, that's a mirror.
part of the lens?
It's a lens for it.
It
Okay,
looks so thick.
now I want to tell you, so you see the astronaut up there taking the camera out, they're in orbit and everything. How many of you like to be an astronaut?
No astronaut.
Me neither.
And then
Okay. This mirror then was in orbit for 3.7 years. Now it's going pretty fast, right?
Yeah.
About 16,000 miles an hour or something, or 17,500 miles an hour for 3.7 years. That's 5.6 billion miles. How many of you heard of Einstein's law of relativity? You heard of that? What's it say?
It means like it is going fast enough to towards light speed. The years in that spacecraft, whatever, will experience shorter time than someone else that's slower.
Yeah. You've been teaching them this?
no.
I just found it out.
I read it in a book.
Okay.
YouTube.
Pretty obvious.
Not
It's
YouTube.
pretty obvious.
Yeah.
Einstein should have known you. Anyway, it changes time, right? So I thought, I wonder how much time change this mirror went through in 3.7 years at 17,500 miles an hour.
No,
Okay,
not that much.
so I calculated. And this mirror is younger than it would have been if it had stayed on Earth by 0.4 of a second.
I knew it was in a lot.
That's hard to tell by looking at it, isn't it?
But that kind of makes sense because it's not close enough to light speed yet. Because light speed is the fastest thing that can ever happen.
It doesn't have to be close to this.
Well, if you want the most noticeable change, then you have to be close to light speed.
The faster it goes, the more the change in time, right?
Yes.
So 17,500 miles an hour sounds pretty fast to us. But what's the speed of light?
Like
Who knows? I don't
100 million miles?
100?
400
That's a
billion,
distance.
100
100 million
billion,
miles per hour.
100 billion maybe.
How many miles a second? Charles is going to tell us.
I don't know. Several hundred million.
186,000 miles a second. Okay, so figure that out, how many times around the Earth. Okay,
Yeah, it's one time around the Earth already. Like 5 times around the Earth in just 1 second.
okay. We've got some time here, I'm going to show you something. You collect stuff, you know, they throw stuff away once in a while and you say, well, that's kind of cool, I'll take that home. And then your wife, after 30 years, says, isn't it time to get rid of that stuff?
Evelyn said the same thing.
I want to ask you something. What's the problem with launching an instrument into space?
Yep, it might rust immediately because it's all made out
Hard
of
to
metal.
fix it.
It won't rust, only iron things rust.
Yeah, it's hard to
Okay,
fix.
and there's no air and there's no
It'll
moisture.
melt. It'll freeze.
Keep talking.
It's going to,
What makes it a challenge to build an instrument for space travel?
Right.
Pressure?
Frost?
Right. Ice.
Ice?
why would there be ice if there's no moisture?
Well, technically there is. There's like a real, just tiny bit of moisture.
Yeah, not enough to cause a
Now, what would be a problem with just throwing you out in
Solar?
space right now? What would happen to you?
suffocating.
No.
Why?
Pressure? Like one of
There isn't any, right? There's no air, there's
No
no
air.
oxygen. So the sun's shining on these spacecraft going around the Earth.
Oh, radiation.
radiation.
On the side the sun is shining on, it gets hot.
Pressure is cold.
On the other side,
It's freezing.
it's facing space. It gets very cold,
Right.
super cold, super hot. Well, an instrument doesn't work very well under those conditions. So what do they have to do?
Insulate it, wrap it in that stuff. Insulate it.
They put them in a sleeping bag, right? They wrap them up. I want to wrap one of you up in this. This is very thin, and they call this multi-layer insulation because there are about 26 layers of it. Now, it's not heavy. But
Super light.
you'll see on this camera in here, it's got a black blanket around it, but underneath that black blanket is this. A lot of layers of that. Now that was plugged into the space telescope, and so it didn't see the sun, but it still had to control the temperature. And they put heaters on instruments, and so they keep the temperature of the instruments about room temperature
Wow.
through the whole mission. About room temperature. Who wants to try this on, see if it warms? Okay. That feel pretty warm?
It actually surprisingly is.
Now you could walk out on a snowy day and it would just keep you nice and warm.
Yeah. Maybe people should put that in jackets. That would be way cool.
Here's a piece of it to remind you.
Oh.
Who else wants to try this on? Okay.
So it's 26
Tear that in
layers
half
of
and
this.
pass it around. 26 layers of that. I didn't count them, but they're in there. Okay.
A jacket. Things are
Warm.
Gets warm pretty quickly, doesn't it?
Yeah.
the one is really cool.
No, it doesn't.
See, the best insulator is a what?
That.
A
Plastic.
vacuum. A vacuum.
That.
You get a thermos bottle, right?
Yeah.
It's inside.
That.
Vacuum.
A vacuum. Okay, because heat can't transfer through a vacuum except by radiation. So in space, between these layers, there's a little, they kind of puff out, you know? So there's a vacuum between all those layers, so it's really a good insulator. Okay, who else wants to try that?
Ethan.
Okay.
I'm not putting right now.
There you go. Space blanket.
Well, you will put after that on for quite a while.
Oh, yeah.
It is actually going to want.
Into
Did that actually go into space?
This didn't.
Why do you have it?
Who do you want in the blanket?
Oh my god, I'm sweating. Oh my god, so hot.
Oh, you wanna try it, no?
Awesome.
Take it to your size there. Getting warm,
Yeah.
you're not getting cold. You walked into a freezer with that, and you noticed. It was pretty effective.
Chris advised also giving off these, yes?
I guess so.
What is this?
That's Mylar. It's a plastic. Made out of oil.
Do it? It's an oily
I'm gonna
plastic.
create a jacket out of it.
All plastic's made out of oil, most plastic.
Yeah, but it'll be too warm. Every time.
Okay. Anybody else? No? Okay, everybody got a piece that wants one? Now, another problem with traveling in space is you gotta launch it and get it away from the Earth.
A lot of pressure.
That takes
No,
a lot
of
Heat or
fuel.
heat?
fuel.
Fuel and pressure.
Now, if your spacecraft is heavier, what does that mean?
More fuel.
More fuel. I don't know the ratio, but if you increase your satellite weight by a pound, it takes,
Like 200 pounds.
I don't know how much more fuel, but then you got the more fuel to get off the ground too.
So that's
So that's more weight. So every pound you can save that you're gonna put in orbit saves a whole lot of money and fuel. And so when they
That's
put
my suggestion.
the things in space, they try to make them as light as possible. I'm gonna show you a mirror that was made for space. This is a flat mirror, and it was a reject, and so I got it.
Why was it reject?
There was something wrong with it, it didn't quite meet specifications. But they wanted this mirror to be optically flat, I mean super flat, so they can do imaging with it, and they, I think it was for a spy satellite or something. So to make it light, they made it like an egg crate.
Whoa.
This is all fused silica, this is low expansion material.
It's so hard.
Now, this was made back in the 60s, a long time ago. And these are the mounting screws for it. Then something went wrong and they rejected it, so I pulled it out of the track. Anyway, this mirror would probably cost at the time about $50,000. Because if it were solid glass, it would weigh about 3 times as much. And 3 times as much
Is a lot more fuel.
costs a lot more to launch. Okay, so the weight of spacecraft is super important.
But isn't it possible to make a spacecraft that's super light, but it's super strong, like made out of some kind of material?
Okay, that's a good question, and the whole area of materials is super important, and they're always doing that. Anybody want to be a chemist? You can work with developing new materials. One of the best materials they have now is a carbon fiber. Yeah, you heard about that. Very, very strong, very, very light. They're always working to make things lighter, stronger, and stiffer, because a mirror has to be stiff so it won't bend. Okay, that's about it.
Carbon fiber is
Here you
strong,
can,
but
here you can count the
like
layers.
it's not just
A lot of layers. There are people at JPL who are blanket specialists, and they'll make blankets for spacecraft. They'll put a pattern on there and cut it out, and then they'll make the blanket, they'll put all the layers together, and then when the time comes, they'll stitch on the blanket and wrap it all up. What's another problem with putting something in space? Let's say we've solved the temperature problem, okay? We can use heaters and blankets.
when you launch it, the pressure is very high, and it might,
Max Q.
and then the vibrations, it might match the vibration of the actual spaceship, so it might completely fall apart.
Okay, that's important. The vibration of launch is fierce. At JPL and all these other places that build spacecraft, what do you think they have to make sure that an instrument can survive launch?
Something soft, spongy,
Bearings.
I couldn't understand what you said. Bearings. But they want to test it under severe vibration to make sure it doesn't come apart during launch. So they know the launch vibration profile of each rocket. Okay, they know what it's going to shake like. So they have big instruments up there that they can shake. It's on shake tables. And they'll put an instrument on there and they'll shake it just like it's going to see when it's launched, and then they increase it by about twice. So they shake it about twice as hard as they'll ever see during launch. And when we had the Mars observer camera on the shake table and watching that shake, it is scary, because you've been working on this for 2 years, right? And this thing starts shaking and making all this noise, and the thing starts vibrating, and you think, and then when it's all through, you go, it survived shake, and that's always a big part of building a spacecraft, surviving shake. Now, why would you want to put a telescope in orbit like the Hubble telescope? Why go to all that trouble to get a telescope up there? It's a lot easier to build a telescope on the Earth.
You can take better pictures.
Why?
Because in the atmosphere distorts light. So you build a telescope from Earth, all the atmospherical atoms and things, it'll distort the light coming from space and stars out there.
That's right, very good.
We can take a picture of Earth.
You can take a picture of Earth from space. Yes, if you're going to do spy satellite work.
The Russians.
So are they still building big telescopes on the Earth?
That's, no, not now. They're building it, they get all the pieces and then they assemble it.
They're still building big telescopes on Earth. Where do they put them?
In the giant chamber.
They put them in downtown LA?
Oh.
No, please don't.
What's
Light pollution.
light pollution, right. Mount Wilson, how many of you have been to Mount Wilson? Griffith Observatory, how many have been to Griffith Observatory? Okay, see if you can talk somebody into taking you up to Mount Wilson sometime and getting a tour up there. There's a 100-inch telescope up there that was built way, way back in the 1920s or so.
All right,
It's still in operation.
sounds good.
The Hooker Telescope up at Mount Wilson. It's an interesting ride and an interesting place. And if you look at these mountains up here on a clear day, you'll see the observatory domes up there. How many have seen those? Now, there's a solar telescope up there and a big Schmidt telescope and the Hooker telescope. Anyway, it's an interesting place to visit. It's kind of like a museum, but it's suffered from light pollution because of all the lights in the valley down here. So that limits the value of the telescope on Earth with light pollution. So the best telescopes now are put in Hawaii up in the mountains. They have big ones over there. Chile and South America.
Well, thank you.
And they do some amazing things. They can compensate for atmospheric turbulence in sneaky ways using lasers and stuff. So it's all very interesting. I studied physics in college, and I liked physics because it covers so many areas. And you can go on any direction: optics, energy, sound, so many different areas of physics.
Are you gonna talk about the picture by the door?
Maybe, oh, I've got to talk about this picture. Let's see. I was waiting for, I've been giving all of you a little quiz. I'm going to give you a hint. I have a picture here, it's one of my favorite pictures. I first saw it over at Caltech. And this was taken by Cassini,
That's Saturn's
Saturn's ring.
That's me. That looks like there's like 2 billion.
Doesn't that look great? See the difference between this picture of the rings and that picture of the ring?
And that one was like all, that looks so blurry.
That was taken with the Hubble telescope
Hmm.
from Earth orbit. This was taken by Cassini in orbit around Saturn. Okay?
Wow.
Now,
That's
that-
pretty.
does that look similar to anything you've ever seen?
No.
Oh, your matches your tie.
Good observation.
The reason I wore this tie is
Saturn's ring.
it's a photograph of Saturn's rings
Wow.
through the cameras that I've worked on. So
Ah.
I just took a photograph off of the internet and sent it to this tie company in Colorado and had them make 5 ties for me. And I gave one to each of our sons and one to a couple of friends.
I want a tie like that.
That'd be great. And the person who said, Mr. Steimle, your tie reminds me of Saturn's rings, I was going to give him this picture.
Yeah.
None of you did it, so forget it.
Mr. Stein, that's amazing.
And since Nathan set this whole thing up, I'd like to give you this picture. Ethan.
Oh, Ethan. Yes, what do you say?
So they can-
He-
Well, yeah. Well, we want to thank you for taking your time to do this presentation.
Glad to
It's
do it,
amazing.
glad to meet all of you, glad the moms could come. And you're welcome in our home anytime.
By the picture by the door you're gonna talk about.